Good morning, everyone. Welcome to the last day of reInvent. I hope that you enjoyed all the sessions, the boot camp, and the workshop that they were available for you throughout the week. Let's start with a quick question. How many of you here were in reInvent last year? Can you raise your hand? Wow, good percentage. Welcome back to reInvent. Everybody else, welcome to your first reInvent. My name is Zahir Dannawi. I'm a product manager with AWS Identity and Access Management. I will be your presenter this morning, and I will be covering identity and access management best practices. Many of you here, they have organizations that are growing. And as an organization grows, new users, new developers, new contractors join your team. And each one of them, they need a very specific access level to your AWS account. Also, you have new managers and new administrators joining your team. And these users, they have a different level of access to your account. Also, as your organization grows, you have to deal with the new complex use cases. For example, you need to grant users outside your account to access your resources within your account. Or maybe users that are outside AWS, and you want them to federate to your account to access resources such as Amazon S3 bucket. As IAM administrator, you are responsible for managing the identities and the credentials of all the users and deal with all these complex use cases. Not only that, you are responsible also to maintain high security of your AWS account. How can we help you with all this? Not only maintaining high security level of your account, but also managing all these use cases in a very easy way. IAM best practices will help you get started on this mission. I will start the presentation with a quick overview of IAM. Then I will start talking about the IAM best practices. At the end of the presentation, I will share with you a couple common use cases. And throughout the whole session, I will be showing you a lot of demos. So let's get started. AWS Identity and Access Management is a free service within your AWS account. It helps you, or it enables you, to control who can do what in your account. Within the service, you can create roles, you can create groups, and you can create users. And for each one of these, you can author a policy, an access policy, and attach it to them in order to give them permission to do action in your account. AWS Identity and Access Management also enables you to have a central control of your account. From one location, you can view all the users and see how they are grouped and what roles that they can assume. Also, within IAM, you can give them a very tailored access permissions. I'll give you a quick example. Let's say you have a user, Rob, that need access to Amazon S3. You can author a policy, give them only access to S3. And in this way, they cannot touch anything on any other service. Even more, you can select the actions that Bob can call within S3. You can give them read-only access in S3 or read-write access in S3. Also, you can control even more what resources Rob can touch. Within AWS Identity and Access Management, you have two ways to access your account. You can control this. You can, for example, enable Rob to only access your account through the console or to access it through a programmatic access. When it comes to security, by default, when you create a user, they have a deny access to all the resources in your account. They can only log in, and they cannot see, view, or modify any resources that you have, not until you author a policy and attach this policy to the user. You can create as many users as you need in AWS Identity and Access Management. And for each user, you can create a unique set of credentials, and you can select the permissions that these credentials can have in your account. So this is my quick overview of the Identity and Access Management. So let's start with the 10 best practices. I divided the Identity and Access Management best practices into 3 categories. The first one will be focusing more on how you can manage in the best way the identities and credentials in your account. Then we're going to cover what are the best practices regarding access permission management. And finally, we're going to tackle a couple of use cases when you need to delegate access or share access between accounts, and also we'll look at auditing. Let's get started with the first category. Create individual user in your account. Let's say on Monday, you have 10 new developers joining your team. You can easily create one user with one set of credentials and share all these credentials with all the users. By doing that, maybe it's easy for you, you'll create in the future a lot of problems. Let me give you an example. Let's say one of the developers decides to leave your company. To ensure high security, you have to quickly revoke the access for these credentials. By doing that, you will impact the productivity of all other users. Another example, let's say one of these users are doing a very good job and you want to give them a higher level of access. So you need now to go create a new set and give them, or even worse, you can go and upgrade these credentials for everyone, and in this way, everyone, they have a higher access in your account, which is really not good. The key points that I want to highlight in this best practice. For the root credentials, if you don't need the use of these credentials, delete the credentials and don't use them. If you are IAM account owner, create a IAM user with administrative access and only use this user. And most importantly, don't share credentials. Always create individual users. The second best practice in this category is configure a strong password policy. We all know that a strong password, a complex password, increase the security posture of the data and protect the data. We all do that in our life. When we select a password for our bank account, for example, we always make sure that it is very unique password and very strong password to protect our bank account. And also, we do the same to protect our privacy when it comes to social media. So why should you treat your AWS account differently? Now the situation gets more complicated. How you can make sure that all the users in your account, they are selecting a strong and complex password. They are not selecting password as a password, or 1234 as a password, or the name of their pet as a password. You can achieve that by configuring a password policy in your account. From the console, with a few clicks, you can enforce on all the users to select a complex password, for example, at least one uppercase, one lowercase, one digit, one symbol, and you can enforce on them to change these passwords every X number of days. So we covered now the password. So what about the access key and secret key that they use in their programmatic access to AWS account? These keys by nature are complex and really hard to guess because it's a string of random characters. So we don't have a problem with this. But these credentials are long-term credentials, and they don't expire. So what we recommend in this, rotate these credentials regularly. Why? Because it reduces the window of any unauthorized access. If your user misplaced these credentials, or these credentials got stolen, the bad actor, they cannot have a long period of access to your account. Rotate the credentials for 10 users might be easy and manageable. But what if you have hundreds of users, thousands of users? This will easily become a burden on you. So what we recommend is to author a policy and enable your users to rotate these credentials themselves. And you can liberate yourself in this way to focus more on auditing the rotation. How you can audit? You can use the credential report that you can generate in your IAM console, and the credential report will give you all the metadata regarding the access keys. For example, you can see in the credential report when the access key were created, when they were last used, and when they were last rotated. So how you can basically enable credential rotation for IAM users? You create a group, and you author a policy enabling the users to create credentials and change these credentials. So this is an example of the policy that you can author and attach it to the group, and you join all the users in your account to this group. After that, each user, they have to follow a very simple few steps to rotate their credentials. Let's go through these steps. They have to create a new set of credentials, and they go to all the applications where the old sets were used. They replace the old set, and they deactivate the first set. And they check. If everything's going well, there's nothing got broken, all good, then they can go back and delete the first set. The last best practice within this category is enable MFA for privileged users. What is MFA? MFA is a multi-factor of authentication. It adds an extra layer of protection when it comes to the sign-in time. So the user, not only they have to provide a strong and complex password, but now they have to provide a new code generated by a token. Currently, AWS supports two types of multi-factor of authentication. You have the virtual MFA and the hardware MFA. The virtual MFA basically is an application that you can download on your smartphone, and you can assign it to a user. For the hardware, we support through Gemalto two types of hardware shape. You have the token, the fob shape, and you have a more convenient shape, which is the credit card, that it fits very well in your wallet. Regarding MFA also, what you can do, you can author a policy and protect very specific actions that no one can call these actions unless they have authenticated with a MFA. I will show you an example in the demo. So in the first demo, I will create a new user called Rob. I'll enable MFA for Rob. And then I'm going to set a new password policy for my account. So here, I'm logged into my AWS account using an administrative user. I'm going to go to IAM console. On the left-hand side, I click on users and add user. So the name of the user is Rob. And here I can select what type of access I'm going to enable Rob. I can enable programmatic access or console-only access. For now, I'm going to give him only console access. I'm going to give him custom password. And as you can see here, require password reset. You can require for the user, after they log in for the first time, to select a new password. And this way, the administrator doesn't know the password of the user. For the demo here, I'm going to unclick it and go next to the permissions. Now, on the permission side, you can easily attach a policy or give the user permissions in your account. You can select to the user to join a specific group or copy the permissions from another user. Let's say Rob, he will be doing the same job as Alice. You can copy the permission from Alice to Rob, and in this way, you know they have the same permission in your account. And finally, you can attach a policy directly to the user. As I delegate the credential rotation to my users, I'm going to add Rob to manage credential rotation group. I'm going to click next. So here is a quick review of the user. Create a user. So now Rob is created, and here is password. And you can click on Send Email. You can quickly send a pre-authored email to your user, explaining to him how they can access your account. In the email, there will be a URL of your account and their username, the password you have to send it to them in a different email for more security and protection. Close. So now I have Rob here. So let's enable for Rob MFA. From the Security Credentials tab, I'm going to go Assign MFA Device. Click on it. As you can see, there's two types I can select from. I'm going to select the virtual MFA device. I'm going to get ready my application. I'm using an application that I downloaded on my smartphone. Create ad. So now you have a QR code. I'm going to scan the QR code, enter the first six. Now I have to wait up to 30 seconds for a new code to show up on my phone. You can also configure or assign it by just clicking on secret key and take the secret key and enter it manually instead of taking a photo of the QR code. Do I have another QR code? So now Rob has a MFA assigned to his account. Let's switch to another browser and log in with Rob. Oh, it didn't get the MFA. So in IAM, you can see Rob doesn't have any access except one thing, which is rotate your access key. So he can manage user access key. You have to go to security credentials. And you can see he doesn't have access to anything except creating access key. So I see and close. And now you can see that he has access key. So let's switch back to the admin user and configure a strong password policy for the account. I'm going to the account settings. And as you can see, you have a lot of options to select from. I'm going to select at least minimum 10 characters, one uppercase, one lowercase, one number, one symbol. And I'm going to enable my users to change the password without coming back to me. I'm going to enable password expiration. I want them to change their password every 90 days. And even for more security, to avoid your users to select the same password every single time, you can prevent password reuse, and you can select how many passwords you want the system to remember. I'm going to select 2 passwords and apply password policy. As you can see, with few clicks, you can increase the security posture of your account. If you don't have a password policy in your account, please, first thing on Monday morning, go and enable a password policy to your account. So let's show you now how you can protect actions using MFA. I have a policy. It's called IAM access with MFA. Let's review it together. Oh, not that. So as you can see, the effect, I'm allowing all IAM actions on all resources, but I added a condition. The condition is saying the multi-factor authentication must be present. And this way, the users, they have to authenticate using MFA in order to do any IAM actions. Let's switch back to the presentation. So we covered the identity and the credential best practices. So let's move now to how you can manage, in a good way, the access permission of your account. And the first best practice in this, manage permission with groups. So what we recommend is create groups in your account that make sense for your organization. You can create groups based on teams. You can create groups based on environments such as development or prod. And for your teams, you can create one group for the developers, one group for your finance team, and give them access only to billing information. And you can create a group for your sales team and business developers. And you can give them a read-only access to this, to your account, because you don't want to give them a read-write access to your account. Groups will help you tremendously to manage permissions. Let's say a user has to work on a new project. You can easily add the user in the group for example, Project Alpha. And also it reduces the chance that the user might have accidentally an excessive access in your account. And also, if you have all the users are grouped in a group, you can just change the policy attached to the group, and in this way, it will be replicated for all users. The second best practice within this category is grant least privilege access. It's always easier to relax the policy than to tighten it up. So always start by giving your users the minimal amount of access to do their job. Because I can guarantee you, you will never be in a situation when a user is going to come and tell you, I have a lot of access, please reduce the access for me. It's never going to happen. But I can guarantee you on the other side, they will always come and tell you, I need access to EC2, please give me access. Or I need access to S3, please give me access. In this way, you control more your AWS account. You can use Access Advisor in your IAM console. Access Advisor will help you to identify overly permissive policies. You can go see through Access Advisors the policy, what type of services it's enabling, and who are the entities that are using this policy and accessing services, and when the last time they access a very specific user. During the demo, I will show you how you can identify an excessive policy and how you can tighten it. So in this demo, I will create a group and attach a policy to it. Then I will manage user permissions by changing the group membership, and finally demonstrate to you how Access Advisor can help you identify overly permissive policies. So from IAM, I'm going to go to Groups, create a new group. Let's call it Project Bravo. And I'm going to give access to S3, full access to S3. Create a group. Now the group doesn't have any users as shown here. So let's go to users and add Rob to this group. Let's click on Rob. And as you can see now, Rob has access to change his credentials and full access to S3. Let's quickly check if Rob has access now to S3. So now Rob can see all the buckets in S3. Let's check if he has access to EC2, for example. As you can see here, he doesn't have access to it because I didn't enable him to access EC2. So let's say you are leaving for a short vacation as IAM administrator, and you want someone to control the account while you're on vacation. So you need to give one of the users access as administrator. Instead of authoring a policy or attaching a policy to the user, you can easily do that by going to Groups, go to the Account Admin group, and add users to it. Let's add Rob, add user, and you can see if you refresh, it didn't apply yet. So it's getting in now. So you can see it start getting access to EC2. The network's a bit delayed. All right. So now you can see he has access, and he can basically manage the account while you are on vacation. When you come back from vacation, it takes only a few clicks to go back. You go to the admin group, remove user, click on the user, and you remove the user. It's very easy and very simple to manage permissions when you use groups. So let's see now how Access Advisor can help you. Let's select a group, like for example this one, Access Advisor. So here are all the services that this group is granting access to. And you can see the policy granting these access to the service. And you can see what user or entity are accessing. And here the last access dates. So I access EC2 today, yesterday I access SNS, and I didn't touch any of all other services. So let's go to a policy, and you can select a very specific policy that I authored for Project Alpha. Let's go to Access Advisor and see if it is overly permissive or not. You can see this policy is providing access to EC2, S3, CloudWatch, load balancing, and auto scaling. And Alice did all these actions, and the last time that she accessed these services 5 days ago. But she never accessed auto-scaling. You can check, does Alice need auto-scaling? Is there any use case that she might need it? No, she doesn't need. So you can go to the policy document and edit it to remove auto-scaling. I'm going to click Validate. The policy is valid. Save. And go back to Access Advisor. As you can see now, auto-scaling has been removed, and we shrunk the access permission of this policy to only the services that Alice needs to do her job. Let's switch back to the presentation and look at the third category. Delegation and audit. The first best practice is use IAM roles when you want to share access or delegate access. Let's have an example. Let's say you have 2 AWS accounts, and you want a user on account for development to access a very specific resource in your prod account. What you can do, you can take these credentials and use them directly in the account. But in this way, you have long-term credentials to access the account. And you don't have much control on this. So what we recommend is use IAM role. Why? Because when you assume a role, we generate for you a temporary, a short-term credentials that they live for hours and they are not permanent. And these credentials, you have to renew them regularly in order to continue to have access. So if someone managed to get access to these credentials, they won't have a permanent access to your account, but for a very short period of time. You can use roles to delegate access from another account to another, or from within your account. For example, if you have a very sensitive actions that you don't want anyone in your account to access these credentials with long-term credentials. So you can author a policy, attach it to a role, and enable the users to assume the role. In this way, they can only call these actions using short-term credentials. And if you have users outside your account, and even outside AWS, such as on-premise, you can use roles to federate these users into your account to do actions. So let's see how all this works. The first, you have a developer, which is our developer Rob. His identity resides in the dev@example.com account. And you have another account, which is your prod@example.com account. And you want Rob to have access to DynamoDB and the prod to do his job. So what you need to do? First, you have to create a role in your prod account called DynamoDB role. Each role comes with 2 policies. The first policy is the trust policy. In this policy, you have to identify who are the principals that they can access this role, who can assume this role. As you can see here, I enabled all entities coming from this specific account, which is my development account. The second part of a role is the access policy. So after the user from the prod, from the dev, assume the role, what type of access will have? As you can see in this policy, the user will have access to this list of DynamoDB actions. So now I prepared everything on the prod side. So what about the dev side? As you know, when you create a user, they have a deny access to everything. So you need to give this user, Rob, access to assume the role, to call the API assume role. So you have to author a policy and enable STS assume role. And as a resource, you're going to limit him to only assume one role, which is the role that we just created in the prod account. So how the mechanism works. Rob has to assume the role using his credentials and call the prod account. The prod account will respond with a short-term credentials. These short-term credentials, Rob can use to call the list of APIs that are shown in the access policy of the roles. So now you enabled a cross-account access using roles. And it's very important to highlight here that we are using short-term credentials, not long-term credentials. In this way, you are delegating access to other accounts, but you're limiting the risk because they can access your resources with only short-term credentials and not long-term credentials. This is very important best practice. Let's say you have an application running on EC2, and this application needs access to S3 to save a bucket, to save like a file in a bucket, or retrieve a file from the bucket. What you can do, you can create a user, generate a set of credentials, put these credentials on your EC2 instance, and let the instance call using these long-term credentials of the user. But this is not the best practice because you have long-term credentials are on a EC2 instance. If someone managed to access the EC2 instance, they can access these long-term credentials and have access to your account. You don't want that. So what you can do, you can launch a role, launch the EC2 instance with a role. And automatically, in the back end, we assume the role for you, generate a short-term credential, and save it on the EC2 instance. Not only that, we rotate these credentials multiple times per day. In this way, you have always a short-term credentials on your EC2 instance. It works very well with SDK and with the CLI. The last best practice within this category is auditing. So now you created individual users, you group them into groups, and you have a very nice isolation between each user, what they are doing. But how you can check or audit who's doing what in your account, who deleted the S3 bucket, or who terminated the EC2 instance. What you can do, you can enable AWS CloudTrail. AWS CloudTrail takes all the logs, the control plane API that they took place in your account, and save them in a S3 bucket in your account. I want to highlight some key points here. Make sure when you enable CloudTrail to enable it for all regions, even in the region that you don't operate. Why? Because if someone created a new instance in, let's say, Europe, and you don't have business in Europe, it will show up in your CloudTrail logs, and you can go and react to it. So it's very important to enable CloudTrail for all regions. The second most important thing, when you save the logs in S3 bucket, make sure that this S3 bucket doesn't have a public access. That it means that no one from the public internet, they can access this S3 bucket. It's very important 2 points here. So let's move to the demo. In this demo, I'm going to show you how you can switch role. Basically, I'm going to assume a role in my account to have a very specific access. Then I'm going to launch a EC2 instance with a IAM role and show you how you can access this EC2 instance as well. And finally, enable CloudTrail in your account. So go back to my account. So first, I'm going to go to roles. and create a new role. Call it access to S3. Next. So this is going to be a cross-account access type of a role. I'm going to do between accounts that you own. I'm going to select. Now I need the account ID. I'm going to use the same account. In this way, I will be assuming role within my account. But if you want to do a cross-account, you put in the account ID of the other account that you want to access. But in this demo, I'm going to just get my account ID. You can require MFA. It's a very important point here. If you want to add or increase the security of your account, you can request whoever coming from outside your account and assuming this role, they have to come with credentials that the user got after authenticating with MFA. And this way, you can increase even more the security of your account. For this example, I'm going to keep it unchecked. I'm going to give a full access to S3. Next step, create a role. So now I created the role. How I can assume this role from the console and switch to it. From the upper hand side, I can select switch role. Then I click. All right. I have to select the account ID, which is my account. The role name is access to S3. I can select here a friendly name that I reinvent and give it a color and do switch role. So now, as you can see, I'm not logged in anymore in my account as the admin user. Now I'm playing the role of access to S3. And you can see I lost my access to IAM because the policy that I attached to the role give you only access to S3. So let's check if I have access now to S3 or not. As you can see, I can see all my bucket in the S3. So how I can switch back? Very easy. You go, you click back to the admin, and you are back using the credentials of the admin. So for example, you can use this mechanism if you want to do very sensitive actions, and you don't want to use it by using a long-term credentials. You create a role when you want to terminate, for example, EC2 instance. You switch, you go terminated, and you go back. And this way, when you do the action, you do it with temporary credentials, and you never use long-term credentials. So that's the first demo. The second demo, and it's going to be a bit long demo, we're going to launch a EC2 instance with a IAM role. So I'm going to go to IAM and go to roles and create a new role. Let's call it project beta. So the type of the role now, it has to be Amazon EC2 because I'm going to use it with a EC2 instance. So I'm going to select EC2. I'm going to give this role a full access to S3 and full access to EC2. That means that the application running on the EC2 instance has full access to EC2 and has full access to the S3. So I created the role. So now the role is created. So let's go launch a EC2 instance. Go to EC2 and launch an instance. I'm going to select the default AMI here and go with D2. So now I have to click on Configure Instance Details. I'm not going to go in details how you select the VPC and all this because it's not related to our topic today. The only thing I'm going to change is the IAM role here. I'm going to select the project beta, the role that I just created. And then I'm going to go to review and launch. Here, just give me a warning. And then I go launch. I'm going to select SSH key that I have in my account. I'm going to create a new one. I acknowledge and launch the instance. Go back to view instances. You can see now my instance is pending and is getting launched. So let's have SSH to another instance that I already prepared. Let's select one of these. As you can see, I launched this instance using a different roles called project alpha role. So let's quickly go review the access of this role. So we go to roles, project alpha, and we have the same access level. So now I'm going to go to Putty and select this project blue, load it, and open it. So now I SSH to the equivalent instance, EC2 instance, and let's see what type of access we have. Let's go do AWS S3LS. List for me all the buckets. So I can programmatically now, or the application can access all the buckets. So let's say you did a mistake when you created the role, and you need to increase or decrease the access of this role. You can easily do that. You can go for the project alpha role, select, for example, Amazon S3, and detach it. So I remove the access from S3. Now the application on the EC2 instance won't have access to EC2. Let's quickly check it. Now I have denied access. You can use the same mechanism to give DynamoDB access or any other access to any service in your account. So that's the second demo. The third demo is enable CloudTrail in your account. So I'm going to go to CloudTrail service. I already have CloudTrail enabled, so I'm going to show you how you can create a new trail. So go to Trails, add a new trail. Let's say my CloudTrail 2016 is already, so like 2016. Apply trail to all regions. I'm going to keep it like this. Create a new bucket. In S3, I'm going to create it my new trail. 16. Go to the advanced. You can select to encrypt all the logs in S3. Automatically, all the logs generated, you can encrypt it before saving it in S3 by selecting encrypt log files, and it's already integrated with KMS, the key management service. For this example, I'm going to keep it as no encryption. Don't forget to enable log file validation. This way, all the logs get validated. Even you can select to, whenever you receive a new log in your S3 bucket, to have a SNS topic sending you a notification to take action on it. So for example, you can put Lambda on top of the SNS. You can go open the log file and process it, and you look for very specific actions that you don't want them to happen in your account. And in this way, you can be very fast to react to any bad actions happening. So I'm going to do create. And now I have a new CloudTrail in my account. Just to take a few clicks, and you have now more protection, and you have a new tool to audit your account. Let's switch back to the presentation. All right. So I have here the last IAM best practice, which is reduce and remove the use of root credentials. I touched about it in the first best practice, but I want to highlight this best practice. It's very, very important to not use your root account user, because this is the master key of your account, and it's very powerful. And there's no need for it to use it. So delete the access key and select a strong password for this user, and even enable MFA on this user. So here the IAM best practice, I'm going to recap them quickly. Create individual user, password, rotate your credentials, enable MFA on privileged users, use groups to manage permissions, and grant least privilege. When you come to sharing, use roles, launch EC2 instance with IAM role, and enable CloudTrail for auditing. And finally, don't forget, you don't need to use your root credentials. Always use IAM users. So there's a couple common cases I want to cover with you today. First one is tag-based access control. And the second one, some thoughts regarding accounts management. So let's start with the first one. Control access using AWS resource tag. So what do we mean by this? What you can do, you can have your resources, you can tag them with a very specific tag, and control who has access to resources tagged with this specific tag. In this way, you can treat your resources in one unit, and you don't need to go back to the policy whenever you create a new resource and add it to the resource list. In this way, it's much easier for you. And it's automatically the user will have access whenever a new instance is created or a new resource is created. Currently, not all the services are integrated with tags. We have here the list of the services. We are working on definitely increase the integration of all other services. So how tag works? So you author a policy. That's an example of it. This one providing access to EC2 on one condition, that the resource here, it must be tagged with a project blue. So Rob, let's say you created an instance in your account, and Rob has access to it. And you create another instance, and you give Rob access to it. But this is going to be very heavy on you. So instead, use the tagging and give Rob access to this tag, and all subsequent instances, Rob has access to them. Let's say you created a new instance that is tagged with project green. Rob won't have access to it. Even though in the policy you see that he has allow on all EC2, because there's a condition, the condition will help you to tailor down the access permission on what you need specifically. So let me show you a quick demo here on how this will work. All right, I still have time. So go to services, IAM, go to policies, project blue. Let's review quickly the policy. As you can see, the first part, I'm allowing a describe and run instance access to all resources, so the user can create resources. But I'm limiting the terminate, the stop, the start, the very important API within EC2 that they are really on the control plane side, and putting limitation on them that only the user have access to project blue. So what we can do is attach this one to Rob. So now Rob has access to project blue. Let's go check quickly. On Rob, did I remove the? So it has project blue and credentials and S3. So let's refresh this. Go to EC2. Run instances. And let's say Rob, he wants to terminate this instance. He will have deny access because he doesn't have access to project green. So let's cancel and go to another instance and terminate this or stop it. So he managed to stop it because it has access to project blue. All right. The last use case that I want to cover with you today is some thoughts regarding account management. I have a lot of customers that they come and ask me, what's the best way to manage my infrastructure environment on AWS? Should I put everything in one account or create multiple accounts? So what is the best way? There's no only specific best way. It comes to your use cases, and it depends on your basically management. So from the account management, use single AWS account if you want to make it simple control for you. And this way you have one account, you can see everything in one account, and you can have all your environment in the same place. And you don't need a lot of isolation between projects, between teams, and between environments. And also, you don't need to break up cost. All the projects and all the environments, they go to the same bill, so you don't need this. On the other side, use multiple accounts when you need complete full isolation. You want project people that are working on specific project, they cannot see what's happening on the other project next to them. And you want, for example, the dev environment completely separated from your prod environment. So that's very important. And also you go with multiple accounts when you want the recovery data or the auditing data to be completely separate. And finally, you use multiple accounts if you need one bill. However, you want to break out the cost between projects and between environments. You can have a one bill because you can select to have consolidated billing of your accounts. And we announced earlier this week the availability of a new service, which is AWS Organizations, and this will help you even more to have a better management of multiple accounts. So a quick recap of what we covered. IAM best practices, and I shared with you two common use cases, which are the tag-based access control and some thoughts regarding accounts management. Thank you all for coming this morning to this session. Thank you so much.